Alright, so the next step that we're going to do is step 13, which is installing the end stops. So you're going to need your 3 end stop brackets, which are these little triangular L-shaped jobs. 6 of the little spacers, just little round circular items. Your end stops, I'm going to set the cables aside for the time being. End stops. 3 cap head 8mm bolts, 3 T-nuts to go with it, 6 nylock nuts, and 6 of the 16mm cap head nuts. Now the way this works, grab a end stop. If you look at the end stops, we have a plug side, we have the micro switch side. Plug side's white. You're going to take your 16mm cap bolt and put it in the hole closest to the micro switch and furthest away from the plug. Grab one of your spacers, just leave that on. Then you're going to take your servo mount bracket and you're going to put the bolt in the corner of it. Then you're going to take one of the nylocks. You're going to tighten that up snug, relatively snug. Okay, great. You're going to take another 16mm bolt, put it in the hole in between the micro switch and the plug, slip a spacer in between the two, repeat the process. Tighten those down. Tighten them down, but don't tighten them down so much that you crack the acrylic. That's bad. You don't want to do that. And finally, to prepare this for getting mounted inside our aluminum extrusion, we'll take a 8mm cap head bolt and a T-nut and just get that started. So that's the setup that we're looking for. There we go. Okay. Make 2 more of those. Alright. Move my hot end down a little bit. See if I can tip this so you can see it. Yeah, I think so. There we go. Gonna put our T-nut in like so and tighten it down. Now, in a perfect world, it would engage. Yeah, it sort of did. But I like to make sure that those T-nuts turn a whole 198 degrees before I cinch it down. So I'm going to back this thing up a little bit and just make sure that that T-nut totally is engaged. and tighten it down well. At that point, now that this is on here, our linear slides cannot come off of the track. So once the end stops are on, it is safe to move these things up and down to the extremes to your heart's content, because they're not going to go anywhere. Alright, now that those three are on, we're going to test the motion. Stand it upright. Test the motion. What we're listening for is a click when our linear rails are at the full height of or top of the travel. And indeed we do. It does appear I need to trim that tail back a little more. So, we're in good shape, and that completes step 13. Step 14 is making the extruder drive. And to do that, you're going to need these plastic items. This aluminum one, this toothed gear, which is actually going to grab onto our filament. Another screw-in push-style connector, small V bearing, two flanged head or tapered head bolts that appear to be 15 millimeters in thread length, and similarly we have two cap head screws that are 20 millimeters long. And all of this came in the same package, at least for me, so it's easy to identify this compared to everything else. So let's see here. Make sure I orient this all right so I give you the proper information. For starters, let's put this on here. Put it on the other side. I'm copying the picture, so I'm putting this push-in connector opposite the little grub screw that's there, tightening it down with a 10 millimeter box wrench. Now I'm going to step aside for a second. Grab my Allen head wrenches, because I'm now going to put the tooth connector on, but I need to get the appropriate Allen head or Allen wrench first. There we are. Back it out a little bit first. I am going to do a little check here, see how deep I need to push it in. So it's still sticking out a bit. There we are. So I'm going to lock that in. Now I'm going to take a bearing this. Trying to push it up. It's going to go like that. So our bearing is going to go on this side here. Awesome. Put our two tapered head bolts in the black plastic housing. And then similarly, we're going to take this aluminum item and put it like so with the cap head screws. And we have just created our extruder. Quite simple. And well, there you go. I did want to add, when making the extruder, you want the little grub screw that sets the gear, or that toothed toothed drive gear. You want the grub screw out towards the end of the shaft. The reason for that is if it's flipped around, since it's off center, it would be somewhat in line with where the filament goes, and then that will interfere with the continual pushing of filament up and out this brass connector here. So make sure that the grub screw is closer to the shaft here when you're tightening it down. And if you got it on backwards, it's simple enough. Pull the two tapered head screws, remove the plastic housing, just flip it around. Alright, so to attach the mounting plate to the extruder, you're going to need to grab your two 45mm cap head screws. There's only two in the kit. Two 8mm cap head screws, and two T-nuts. Now, it's going to be oriented like this, and so what that means is this will end up being bolted right like that. So flipping it over, we need to remove these two screws right now, and by the looks of it, we have Phillips. I'll grab my screwdriver. So, being very careful, we're going to unscrew switch heads. We need to unscrew those two screws. Remember, these four in total are what hold the whole motor together, so you'd never want to take all four off. See the difference in length? Not too much, but just enough to go through this acrylic. I'll put those back in. Grab my wrench. Tighten them down pretty well. Again, don't super duper He-Man them, because then you'll just break your acrylic. Then we will put on the T-nuts. Actually, these are grooved instead of just holes, so I'm just going to kind of make up a couple of T-nuts here and put them on in a moment. That's out of the way. Grab the printer. Now I gotta figure out where I want to mount this thing. I think I'm going to mount it like so. Yeah. So, grab my T-nuts, slip them in the grooves of the mount. These again, sorry you can't see that, but I've put an 8mm cap head screw and T-nut there, and similarly one up here in this groove, about halfway up the rail, and I'm tightening it down. I'm going to make sure that the T-nuts fully engage the extruded aluminum. Alright. Again, you can see, got the mount. Again, the blue plug is pointing towards the top, and our extruder driver, or extruder motor, is on. Alright, so to make the filament holder, you're going to grab these two pieces of acrylic or laser cut plastic, and you grab two of the 16mm bolts, put them through this tapered end here, which will then match an opposite pair of holes on the other smaller tapered piece. You put nylocks on them, so it's two 15mm, two nylocks, and then it'll be two 8mm cap heads and then two T-nuts to mount it to the frame. Make sure that sits level. There we are. You will mount this somewhere along those lines, and what you want to do is check your filament, look at the size of the spool it is, make sure that when it's sitting on here it still has free play underneath, but you want to keep it kind of low, so you want to minimize or keep the center of gravity of the whole machine as low as possible. So I'll install it in about here. Tightening that down, that's it. So, step 16 is installing what they call the PTFE filament guide tubing. It's this white straw-like stuff. Mine is already cut to length. However, I am going to square up the bottom portion a little bit because it's cut in a touch of a diagonal. Anyway, if yours is long, you're supposed to cut it down to, let's see here, 685 millimeters. That works out to 27 inches. If it's shorter than that, I would say don't worry about it. I'm going to start by going into the middle here. What you do is you're going to push down while supporting your hot end until it bottoms out. That'll lock it in place nice. Don't kink it, don't bend it. Just make sure it bottoms out nice and good. I'm going to route this around over here. Do the same thing on this side. Push it until it bottoms out. That's locked in. And that's end of 16. It's pretty quick and easy. But you want to make sure you do route it in a place that doesn't interfere with anything. I'm just kind of going around and dropping down in so it won't interfere with anything. You can also check your range of travel. Make sure that even at the furthest distance away, or top and bottom, that you still have plenty of slack. Alright, now's the time to start assembling the heated bed and the mount for that and getting that installed in the printer. So first thing you're going to need is a soldering iron, and not all soldering irons are created equal. The one that I have here appears to be a, who knows, I believe it's a 20 watt, 25 watt, something along those lines, which is going to be necessary to effectively solder the 14 gauge wires that came in our kit. Now, we're not to the step yet, but eventually we're going to be putting on connectors onto the end of the thermistor. It's this white wire doodad here. I would not want to use the same soldering iron for that. It would be bound to just melt the wires pretty good. So I'd want to go to a lower wattage. So we have a good length of wire here. I'm not going to cut it yet, because what I'm going to do is I'm going to solder these two ends to the heated bed. I'm going to leave them long, and once I figure out the run that they have to make, I'll cut them to length, which will give me maximum length for the other use of these, which is to go from the power supply to the ramps board. So this one length of wire at the moment has two purposes, and I'll have to cut them down when that time comes. Let's see here. Looking at the manual, it appears this is our plus side, referencing the triangle here. Plus side, minus, so red's going to go over here, black's going to go over here, and then we're going to take our thermistor and we're going to kind of just tape it and run it up the front here, or in the middle here. Now you notice that there's some other little pads in the center of here that have nothing on them. I believe, especially considering this screen printing references LEDs, that there's the possibility of putting LEDs on here, or maybe one version of this might have came with LEDs to indicate that the temperature is on, but we all know that this is going to point down into the ground, so you wouldn't see the LEDs anyway, so it's just as well that they're not on there. So to start with, make sure that your soldering iron is nice and hot. Get some solder out. Yep, we're good. And it's encouraged to tin your ends. Now what tinning means is that you basically put a coat of solder on the end before you're going to touch it to the pad. So tin your ends. There's 1, tin this one too. Make sure that flows nicely through the copper wire. And it's good copper wire, so it should have no trouble. If you find that the copper isn't sticking for some reason, you have potentially two problems. One, your soldering iron isn't hot enough or it doesn't have a high enough wattage. Or two, you might need some flux, but again, get a regular soldering iron, probably won't have any trouble. Next thing I'm going to do is I'm going to put a nice pad of solder on these mounting positions. My goal is for a very good electrical connection. And we said this side was going to be black. Goodness. Might need to get a higher wattage solder iron. I mean, I do have a connection, but I want that solder everywhere to be flowing nice. So, let's try the red here real fast. I do need to keep in mind that I'm soldering to a big aluminum plate with a circuit board on it, so it does have the ability to dissipate heat quickly, and that's kind of the enemy when soldering and wanting to make a good solder joint. They're there. I might touch those up a little later. So the next thing you want to do is you want to grab your thermistor. It came in the same package as the heated plate. And we're going to get some Kapton tape. You have a little bit bigger spool than me. I already had an open one, so I'm going to use it. And what we're going to do is we're going to grab some of this, and this is a really high temperature tape, high temperature adhesive, high temperature plastic material that makes it up. And we're going to tape right across the little glass bead at the end. That's where the temperature sensor actually is. There we go. And I'm going to, there's the end. I'm going to put on some more. Oops, Now you can see by lifting up on that red wire, I was able to break the solder connection. That would be a bad solder connection. That's actually going to take me I'm going to need to get a higher wattage soldering iron. But the good news is I have one, so I'm going to do that and solder those pads a little better because they are just not flowing as well as I'd like. So I have taped in 3 places the thermistor. That should hold everything nicely in place. And then when I get my wires soldered a little better, I will tape those down with more Kaptown tape to make sure that any kind of tugging, pulling, whatever that I need to do on these wires doesn't break the solder joints again. But again, this soldering iron isn't quite powerful enough for this job. Alright, so step 17 is now complete, and I understand that I didn't exactly take you along the way with me on this process, but it was a bit of a challenge, and this particular step was a bit frustrating. So we already talked about soldering the leads to the bottom of the aluminum heat bed, and that's fine. That was straightforward once we got the right wattage soldering iron. What I'm going to talk to you about briefly, and I'll turn this thing upside down so you can see what's going on here in a second, is these the 2 pieces of acrylic that make up the mount for this, as well as the Arduino Mega. Every build is going to be ever so slightly different in measurements. I mean, we're talking about using printed plastic parts that will have a slight variation in things. So it doesn't surprise me that, despite the fact that these pieces of acrylic are laser cut, that there needs to be a little bit of what we'll call finesse to get them in. The single bar, if you will, the straight strip, wasn't a challenge at all because you can wiggle it as necessary to get it to fit with the T-nuts in the grooves of your extruded aluminum. What the challenge was that we'll call it A shape or H shape, the part that you actually attach the Arduino Mega to. I always found that as I was putting these T-nuts in, I could get 3 of 4 to tighten up, and then no matter how hard I tried, one would just be out of alignment enough that it wasn't going to work. Or if I was able to get it, I'd have to flex it so much or force it so much that the acrylic would start to bend a little bit. We don't want that because this acrylic is what the heated bed mounts to, and we want to try to keep that as flat as possible and not all lopsided. Now I know this kit does come with an auto level, so it should be able to adjust for that, but if we can prevent it, it's only going to be that much better. So what I had to do is I had to drill out the holes a little bit for the bolts for the T-nuts to give me a little bit more wiggle room, and I actually had to use a needle file, a small round needle file, to kind of oval shape the holes so that I could finesse them in. They went in fine now, but it was a bit of trial and error trying to get it all to work, and that took a bit of time. Certainly not something I want to show you on camera. So I'm going to flip this over now, and we can see a little bit better what's going on underneath. Yeah, we'll do this. So, try to hold this up without my arm getting totally tired. You can see, oops, there we are. We have our H shape piece here that's holding the Arduino Mega, and we have our individual strip on this side here. That was the easy one to put in the acrylic. And we used 3 20mm bolts to hold on, let's see here, right here, here, and there's one up there, to hold on the heated aluminum bed. Similarly, we have 2 nylock bolts and two 20mm cap head bolts to attach the Arduino Mega. Now when you put on the heated bed, you will use spacers because the heads of the screws that hold on the Arduino Mega will stick out and be a little bit proud of the surface of the acrylic. So your spacers will be used to stand off the heated bed a little bit so that there's clearance for the bolt heads, because you don't want those pushing into your circuit board that makes up the heated bed, because that's bound to short at some point. So again, we use 3 spacers on our heated bed, and then some nylock bolts and lengths, nylock nuts and bolts for both the heated bed and Arduino Mega, and then finessing as much as necessary the acrylic so that it fits nicely in the slots of the extruded aluminum. And again, every build is going to be a little different. You might not have any difficulty with that. Mine was a bit of a challenge, but you know, with a drill press and a file, it wasn't too bad. So that wraps up builds or step 17. We're going to then move on to step 18, but I did want to give you an update and kind of show you what I had to do to make all this work. Alright, step 18 is wiring up the power supply. And there's a couple of steps that we need to do for this, as well as a few things that we're going to need to get. First thing is we're going to need 2 lengths of red and 2 lengths of black 14 gauge wire. My wires are about 16 inches long each, and these were cut off of the long lengths that were soldered to the heated bed, the aluminum heated bed plate. There's still plenty of tail left on the heated bed to reach where we're going to need to go, so 16 inches, 2 lengths of that seem to be appropriate. So 2 red, 2 black wires, great. Now you're going to look for your power cord, and you'll see your standard 3-prong Edison power cord end here, and then we have what appears to be a little Mickey Mouse style plug on this end. We're keeping this end, we're going to cut this end. So I'm going to cut this. You can throw this end away. Now, using a pair of wire strippers, I'm going to try to cut the outer shielding without cutting the inner wires. Fun. So I'm left with a green, a blue, and a black. Excuse me, green, a blue, and a brown. Alright, now's the fun part. Since they're not standard colors, I'm going to need a multimeter. This will at least allow me to figure out what wire's going where. So I'll strip the ends of each one of these a little bit, so I have something to work with. Taking my plug or my multimeter and setting it onto continuity. I'm going to take one wire at a time, touch one end to the bare wire, probe plugs until I see one that responds. So my green, as I would expect, is the ground terminal, the round plug on the bottom. Next we'll look at the blue. So my blue is this leg of power. My brown is the other. Okay, so figure that out. I'm actually going to make a note to myself that looking at the plug, green, blue, brown. So now I can look up the wiring here in a moment. In the meantime, we're going to set the multimeter aside. And the plug. And we're going to strip the ends of these 14 gauge wires. We don't need to strip them too much. Just enough that they can go in the appropriate terminals. Now I want you to get your ramps board. Looks like this. In the package there'll be a little, in the package there'll be a small baggie of jumpers. We won't use those right now, but we will need them soon. You may have a solid block connector like this, which has got 4 terminals, or you might have two terminals, which would be separated halfway down the middle. And I want you to look at the orientation of these. So I would go in like this. So these screw heads up here point up. Now if you look really close on the ramps board, kind of underneath these yellow, I believe these are resistors, pretty positive. If you look underneath there, you will see screen printed on the circuit board, a plus, a minus, a plus, a minus. So what I'm going to do, just to make my life easier to remember, so pluses I'm not going to mark anything, but on the minuses I'm going to take a Sharpie and mark a little black mark. So again, it goes plus, minus, plus, minus. So minus, minus. Nothing too crazy, but I've now indicated which ones get the negative power, which will make our life easier because we're going to pull this back off and set it aside, put it back in the anti-static bag, and I'm putting it back in the box that everything came in because we're going to get to this later. So now there's no confusion as to which of these the negative, the black wires go into. Alright, so next step is going to be to start setting up the wires. So I'm going to grab a positive, a red. I'm going to put it in here. I'm going to grab a small flat blade screwdriver. I do not recommend that you use the one that came with it. This is a non-conductive one for adjusting your stepper drivers. Use something a little stronger so you can really cinch down the clamp on the wire. So you back it out all the way first, and then you'll screw it down nice and tight. Give it a little tug, make sure it's in there well. So now we decided that the next wire is going to be negative, that we marked with a little black Sharpie mark. Next one is going to be red. And finally, the last one's going to be black. So now we've created our plug. Wires going in. We've identified that the black marks go to the black wires. Now we're ready to hook it up to our power supply. I'm going to take the two black wires, and looking at this, let's see here. You can see a little green LED on this side. There's also a little orange or yellow potentiometer. That's for adjusting the power coming out of here. So if you find that it's putting out a little under 12 volts, you can dial it up. If it's putting out a little too much 12 volts, you can dial it down a little bit. It is a 12 volt power supply, but that's how you'd adjust it so that you can really hone in the voltage. You gotta make sure I'm looking at this right. So looking at these terminals now, next to our green light, we have 3 that are our positive voltage. The next 3 are negative voltage, and those are positive and negative 12 volts. And then the last 3 are AC. That's what we're going to hook our power cord to. So I've got the 2 negatives with me right now. So we have positive, positive, positive. Great. Negative, negative, negative. So I'm going to open up these two of the negatives. I'm going to slip in, oops, sign here. Slip in the black wires. Tightening them down nice and snug. I'm going to grab my 2 reds. And since there are 3 terminals and I only need 2, oops, I'm going to pick 2 of my 12 volt positive red terminals. You want to make sure you're clamping down or screwing down on the copper, the bare copper, and not on the not on the shielding, because the shielding prevents voltage from going through, and that's what we don't want. We want to have a nice solid connection so voltage can go through. There we go. So you can see, to hit this right, you can see that I've got, we have 1 voltage plus, 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 and I put my 2 pluses in those. Now we have minus, minus, minus. Put my 2 minuses in those, and now we're going to do the AC. Strip these back a little more, just because they're not very long. And for the fun of it, we'll start clamping down our cables. Green goes to ground. And ground is kind of that strange dashed line logo. It's also the closest one to our negative or black wires. So we'll put that in there, screw it down. Now for our other two wires, since mine are not a standard color configuration, I would have expected a green, a black, and a white. I'm going to make sure, since I took notes on what the orientation of the plug is relative to the colors of the wires, I'm going to make sure that I get my neutral and my my hot wires correct. Neutral would be the N on here, and L would be my hot, or I believe they call it line or live. I want to make sure I get those right, so I'm going to look up on the internet and make sure that I don't mess these up. I will be back with you. Alright, after doing a little searching on the internet, I found out that brown is my neutral and blue is my line. So it goes, for me it's green, brown, blue. Green closest to the black negative voltage, 12 volts that we hooked up to our ramp's power plug. That's great. Moving on, you need to grab the two acrylic power supply holders. They're these kind of strange angular shaped items, and two of the 5mm by 5M bolts. You go ahead and screw those on to the power supply. Depending on what side of the power supply you put this on, you might need to flip-flop things to the other side. While I'm looking at it, I do want to call attention to this big yellow sticker in this switch. Mine came with the numbers 110V showing, and I'm in America, so 110 volts is correct. That's what our AC power is. If you find that you have a 220V showing, switch it if you're in America. Other countries do it as necessary for where you're at, but make sure that that's showing before you install all this, otherwise you might get unexpected results. So I've put these two on. It's just the single bolt and those a little bit larger hole for the 5mm bolts, and then two T-nuts on each side with an 8mm cap head. And I'm going to grab the printer again. And the way that I intend to have this mounted is I want to put my power supply on this side. Oops. Like so. Likely need to tip the printer over. So I can see what I'm doing. Well, by the looks of it, I need to do do a little bit of modifying with the needle file again to make sure that I can get these T-nuts all to align in the grooves and be able to be set down. But just to give you an idea, it will mount like that. The cord's coming out towards the back and we'll wrap those underneath. Probably come through right here and go into our ramps board when it comes time to put that underneath. Alright, so I'm going to do a little bit of modifying to this plastic mount, make sure it all fits, and then we'll move on to the next step. Alright, step 20 is going to be to connect the fan on the hot end. And I've jumped ahead slightly to start doing some cable management, so I know about how long my fan leads need to be. But I will say there's a very good likelihood that you will have to extend your fan wires, and it is my understanding that there are no wires that come in the kit to do that, so you will have to source your own wires to extend them a bit. Doesn't need to be too much, but I needed something longer than what came in it. So what I have here are the two leads that run to my fan. And what I'm going to do is I'm going to go to the power supply, and I'm going to use the two extra terminals that are not already being used for supplying power to that fan. Now what that means is that this fan is going to be running anytime that this machine is on or plugged in. I'm okay with that. If you are not okay with that and wanted some other means of control, you might want to put a switch in between the power supply and the fan. Nothing hard to do. Again, doesn't come included in the kit, but it's something that you might want to do. I know some ABS prints work better with no fan current blowing on them. I'm less concerned. And then close up that cover again to prevent shock. So there's our fan lead. That's done. Now our hot end fan will be blowing. The next step is to dress your cable. Now I've already started on that. You are given some loom material or cable wrap. This black stuff here. Use it. I would say start with your hot end and the cables that are running to it. Get that all organized correctly, and then see what you have left. And do your servos, or excuse me, not servos, your limit switches. The provided loom is actually quite nice in that if you splay it out or stretch it out a little bit and then push it into the groove of the linear extrusion, or the extruded aluminum rather, it'll hold wires quite nicely. An example of that is right here. So, and there's a wire in there as well. So keep that in mind. Obviously what we're trying to do is get all of our wires that aren't currently hooked up to anything, i.e. the power supply, ultimately underneath the heated bed, because that's where our ramps board will be located, and that's where we're going to be plugging all this stuff into. So take some time, dress it nice, use some zip ties. These aren't included in the kit, but they are nice to have. These are adhesive little zip tie mounts or zip tie anchors. They just go on with adhesive, and these ones I believe are 1-inch squares, and they stick on to things quite nice if need be, just for keeping things extra tidy. But again, these are not included in the kit. Alright, I will let you to do some, or leave you to do some cable dressing at the moment, and then we'll come back and continue. Alright, hopefully you've managed to tame all of your wires, at least to a decent able to get them to some degree of organized. The next step is to label your motors so that we can keep everything straight once we turn this thing over. And remember, over here, this is going to be my front. This is what will face the user. So furthest back over here, that's going to be your Z-axis. Again, this is the user. To the left of the user, it's your X. To the right of the user is your Y. So let's see, if I tip this back, you can see how I did it. Again, remember, I would be sitting here. This would be facing me. And, this would be back towards the wall. So that's how you should label them. Temporarily, I just use some painter's tape just so I can make heads and tails of this. Now, if you followed along with me this far, I'm going to reward you with unfortunate disappointment, which doesn't make a lot of sense, but it's something I noticed, and there's an easy fix, but you have to step backwards a little bit. I will try, when I post this video, to make a note of this while this step came up earlier, but again, if you're following along and disregarded that, this is what I'm going to show you. Alright, tip this thing up. As you can see, I'm going to pop this up. Yeah, come on. I had to move my ramps, excuse me, my Arduino Mega, get that out of the way, a bit. It's no longer pointed directly in line with that motor in the back there. I had to turn it sideways. And the reason for that is, if this were twisted, you would not be able to get the USB cord on. So that was an unfortunate realization. So do make sure that you basically mount it about 90 degrees from the orientation that I said earlier. Again, I'll try to make a note in that earlier video so that people, when they get to this step, will have already done it. But yeah, you do need to make that change. Otherwise, you won't be able to use a USB cord, which, if your plan was to only use a LCD screen, that might not be a big issue. But if you're like me and want to use your USB cord to send things from your computer to your printer, you are going to need to have that USB port accessible. So again, that was an unfortunate realization that I just made before hitting record again on the camera. So, next thing that we're going to do, I'm going to start hooking up all of our wires and prepping our ramps board. So here's our ramps board. Nice little device here, actually. It's laid out quite nice. Let me explain what you need to do. For starters, those a little package of jumper cables, you need to get all those, or excuse me, not jumper cables, but just jumpers. You need to get all of those out. We are going to hope for 16 of them. And what you're going to do, room here. So here's the green power plug. You're going to fill up the there's 5 banks of 3 pairs of jumpers, or jumper pins. And you can identify these pretty easily because they are in between the 2 rows of female pins. Disregard this stuff over here on this side right now. So we're going to keep going with the jumpers. And I'll show you what this looks like when I've got it done. Now if you forget to do these, this, I believe, is what sets your micro-stepping. and you want the 1/16 or 16x micro stepping because you get more accuracy with that. That means every actual step on the motor, and there's 200 steps per rotation. If you drop that down to 1/16, then it's a multiplier of 16, so you're going to get much more accuracy. And that's what you want. If you wanted to know why you'd want less microstepping, the trade-off is you get torque. But these aren't torquey devices, so there's no need. Okay, so there you can see I've got banks of jumpers. Hello. Right there. And then again, they are the set of two jumpers, or excuse me, 2 pins per jumper in sets of 3, and they go underneath each one of our stepper drivers. So go ahead and do that for a moment, and I'll be right back. Alright, the next thing we're going to do is we're going to install our stepper drivers. The stepper drivers come in anti-static bags as well. They look like these. At the moment they have foam on the back. I want you to look at that real close, alright? Because what you will notice is on this side here there is a little, looks like a little screw. Put a Phillips screwdriver in there. Looks like anyway. That's what we're going to use to identify orientation. Okay, what does that mean? Well, when we install these, we want to orient that little potentiometer, is really what it is, the thing that you could put a screwdriver in, away from the green power plug. All 5, or 4 if you're choosing to omit one like I will, all of those need to point away from that plug. This is important. If you don't do that and you apply power to this, immediately you'll destroy the stepper drivers and you'll have to get new ones. Don't do that. Again, that potentiometer points away from the green power plug on the ramps board. Now I'm going to start and make sure that my pins start in the very first set of holes, and we're going to push that in. Move on to the next one. Again, same deal. That potentiometer is away from the power connector. Now if you come to the end of a row and realize that you have a pair of pins that is hanging off the end, chances are you didn't get it on the first set. So just unplug them and try again. So all 3 over here, and I'm going to put one right here. Feel free to go ahead and put the other one in as well. I'm choosing not to do that right now. The reason for that is this open bank that I have not put a stepper driver in, that would be for a second extruder, and I do not have a second extruder. I don't feel the need for that right now. I'd rather just leave it in the anti-static bag. Now, also included with the stepper drivers are some little heat sinks. Now, these things are good to have. You'd like to put these on because it's going to prolong the life of a stepper driver. Now, what I can recommend is when you put this on, you want to avoid touching the pins or the backside of the pins on either side. So you want to make sure that all this is doing is sticking to the top of that black chip, which is the actual driver. There's the thermal adhesive on these already, which is very nice. Anyway, this will just help keep them cool. And since we have this hiding underneath everything else, underneath our machine, it's just as well that we keep some extra cooling on these drivers. In the future, you may choose to look into getting a ventilation fan or something underneath there, but for the time being I think we'll be just fine with these heat sinks. Now, one last thing that I'm going to say before I plug this onto our Arduino Mega. Just so you're aware, again, referencing the green power plug here, you're looking at the X stepper driver, Y stepper driver, Z stepper driver, and here's your first extruder over here. Okay. While we're at it, since we know that we have a servo for the auto leveling, I'm going to take one more jumper. And you can see the reset switch, it's right here. And there's one bank of 3 jumper pins closer to the power connector. You take a jumper, and we're going to jump the inner 2 most. So hopefully you can see that right up here. Okay. Why did I do that? Because what that's going to do is that's going to allow voltage to power these pins over here. Those are for your servo. So you might as well get that out of the way. So now I've pulled off the foam on the bottom, and this is relatively straightforward. We're going to line up all of our pins and make a bit of an Arduino sandwich. You do want to make sure everything goes in correctly. Rotate this a bit so I can see a little easier, but it does appear that everything is going in as it should. And make sure they seat nice. Alright, everything is good, all of our pins are in. So now our ramps board is attached to our Arduino Mega. We can take our green power connector, the one that we put our black and red power wires on, we can plug that in. Just come on. There we are. Now I'm going to take, I have all these leads coming in here. I'm going to find the 2 for the hot end, and it's easy to identify what those are. What you're looking for, they're going to be 2 red wires, likely 2 red wires. They're going to have a high temperature shielding on them, which is a textured shielding, unlike the smooth shielding on every other wire underneath here. So it's pretty easy to identify them. So here these are. And what I'm going to do is I'm going to strip back a little bit. Now we're going to take, and if you look underneath here, looking at the blue connectors, you'll see something that says D8, D9, and D10, and that's screen printed on the ramps board. These two wires, again, we have identified that these are going to our hot end. These two wires are going to get screwed into the terminals on D10. So we're going to take this, pop it in there, clamp it down good. Now we're going to take this one, clamp it in here. All right. So you can see our two red wires going into D10 there. And I know it has a plus and a minus screen printed on the board, but for our hot end there is no polarity difference, so it doesn't matter which wire you plug into which. Alright. So the next thing we need to do is we need to go and plug in our heated bed. Now our heated bed goes into D8. So we actually have a pair of connectors that is not used in between our extruder and our heated bed. And you might wonder, well, okay, what's the D9 for then? The D9 would be for a second extruder. So on this one, we are going to follow polarity. We're going to plug the black into the negative, which is actually exactly got the screen printing D8 on it. Ooh. Don't unscrew your screws too far. There we go. The gauge of wire we have is pretty good size for these connectors. Come on. There we are. So that was our negative. Now to do our positive. I'm trying to get these so they kind of get out of the way. Alright, so I got the red positive, and that's going into the slot that's identified as plus. Alrighty. Forward progress. Now, let's do end stops real fast since we're underneath here. End stops. Look at, and the way you routed your end stops might be different than mine, but look at where your end stop plugs are coming in. For example, this one here is for my X motor. we're going to position these. Make sure I tell you the right information. Nice. We're going to position these over here on this bank. See the big block of things. Now, what we're interested in is the 3-pin portion, not this 4-pin portion on the bottom, but this 3-pin up here. And the way it works, I said this is my X. The red wire is going to face in, and we're going to go and start on the second row. You might ask why the second row. The first row is for X minimum, the second row is for X maximum. Remember, our end stops are at the top, at the maximums, so that's why we did it that way. The next one I have here is, this one's my Y, so I'm going to skip a row. Plug that one in, and then finally my Z is hiding right here. Skip a row, double check my work. There you have it. So skipped one X, skipped one Y, skipped one Z. Red wires facing in. Again, that's important too. If you flip those around, there's a good likelihood that you'll burn up something on your ramps board. So don't do that. Straight up, don't do it. Red wires face inside. If you haven't already, go ahead and hook that USB cable up. I did. You will find that you can't fit the square end of the USB port or the USB plug through here, so you have to slide the thinner portion from underneath. Lastly, there's 2 things underneath here that we still have to do. Actually 3. It's a lie. We have 4 things to do underneath here still. I need to terminate my servo wires. You likely got an extension cable for your servo in your kit, so yours would already be terminated. We have our thermistor. This one here is for our hot end. This one here is for our heated bed. So we'll have to put plugs on those. And then also we need to put a plug on the 2 wires that we attached to that micro switch on the end of our servo arm for the auto level. So that will get terminated as well. So I have some terminating to do, which is pretty straightforward in that in your kit you are given a little package, a little baggie of connectors. So what we need to do is just strip back a little bit of the wire, crimp that on, possibly solder it a little bit, and then plug it into the connector, and then we'll plug it into our ramps board. So what I'm going to do is I'm going to terminate these, and I'm going to get back to you. Alright, so I have terminated all of my wires, and what I want to show you now is where things are getting plugged into. We talked about the servo. Oops. Needing the jumper right here. Your servo gets plugged right here with the brown or black wire facing out. Right here, that is for your the thermistor for your hot end, and right next to it is the thermistor for the heated bed. We already had all of our end stops, but the other end stop, excuse me, the other micro switch that we hooked onto the servo arm gets plugged into the first from the outside, 2 pins on Z minimum. Remember, the way it works, it goes X minimum, X maximum, which we plug something into, Y minimum, Y maximum, maximum which we plug something into, Z minimum, which is going to be our micro switch on our servo arm, and Z maximum, which is just the end stop at the top of the Z motor. Now, the last thing that we need to do while we're underneath here is plug in our motors. Now, there's 3 short cables and 1 long cable. You just need to plug in, you need to plug the 3 short motors into the 3 short cables, and the 1 long into the into your extruder motor. So your extruder, make sure I get my orientation correct here. Excuse me. Okay. So the green wires are going to face towards the power plug. So this here is my Z motor. So again, X, Y, Z. Green wire is going to face towards the power plug. There are 2 plugs for the Z. It doesn't matter which one you plug it into. Alright, next one's going to be this guy, which is my X. Again, green wires towards the green power plug, and it plugs into my X. You can tell, maybe you can't, but there are some pins just to the left of each one of the steppers, and that's where you're going to plug your motors into. And here's my Y, and green wire faces the green power plug. Here we go. And lastly, which is good because my hand's getting tired, the long cable, which is going to go to my extruder. And again, nothing's changed. The green plug goes to this end. Alright, so now that I have this big rat's nest of wires in here, I can tidy them up a little bit with some zip ties, and then I think we're done underneath here. Alright, I do a little fly around for you, just in case you're looking for something that I didn't focus on too closely. But I'm supposed to say congratulations, you've made it this far. At least that's what it says in the manual. The mechanical portion, including the wiring, is complete. So now it's just a matter of getting the software sorted out. Again, job well done to you for making it this far, and listening to me ramble on forever and ever. Alright, again, this is the Kossel on 20 by 20 extruded aluminum rail by Folger Technologies LLC. They can be found at folgertech.com.